So hello everyone, we are going to continue a series for explanation of different topics, and today I am going to start a new topic for explanation, and that is going to be like the explanation or just the revision for what I have learned in the CA50's lecture, in which I am learning currently about language C. And in that I have completed almost 3 lectures, but due to some circumstances I wasn't able to record video for one, and I have only made notes for the third lecture. And as I started making notes for third lecture, and because it was my vacations, I didn't do much of study and hard work, we can say, in a way. So yeah, let's continue from where we started writing notes. So in the lecture 3, the name of lecture 3 is algorithms, and algorithms are something which are used to change the input we give from the or the thing that is given from the user, and is changed to the output which is received by the receiver, we can say, or which is received by the end of, yeah, of course, user. Algorithms change the thing we send in the input in the way we want, or in the way the algorithm is designed. The input is changed into a particular specific thing that the output is required for. So now then, we in that algorithms video, first topic is binary search. So what do we understand by binary search? Binary search is something like go to half, then divide, and then move to left, go to half of the thing, go to half of the array or the thing we are searching for, then see if the element we are searching is on the left of that middle element or on the right side of the middle element. Then once again go to the middle of the element if it is on the left of the element, and repeat the same process. And if it is on the right side of the element we are currently on, then go to the right element and go to its mid element. Then once again see if it's left or right for the element we are finding, and repeat the process recursively until we find the element. And now as we are seeing bubble sort, it only works if this array is sorted, because if it isn't, if it wasn't sorted, then we would be unable to identify if the element we are searching for is on the left side or the right side from the middle element. And yeah, so we first need to sort the array and then find the element we need to search for. And if we directly jump on the element that is on the middle of the array, then it's well and good, and we would have its best case time complexity as omega of 1, and its worst case time complexity would be omega of log n. So we can perform binaries. Its best case time complexity can be different, but yeah. So yeah, binary search includes different type of searches. So we can do linear search, which is search in a line one by one in sequence. So we need to search in linear search. What we basically do is search from one by one, moving in a sequence to find the element we want to find. So it is a slow process, but we can adopt it to find if we want to iterate just for single row. Now binary search is a search we only search the half portion, starting from half, seeing which position to go, left or right, and repeating this process pseudo. So the pseudo code is given in the form: if element is on n by 2 of the line, then return the element immediately. Else if the element is on left of the middle position, then go to left, and then go to left at the position of n by 2 once again, or the half of from where we are, from the 0th index, from the starting to the position where we are, go to the middle of that, and if the element, else if the element is on the right, then repeat the same process, go to the middle of the position from where we are in the middle of the position till the end, go to the middle. And if nothing works, if the element is not in the array, the worst case scenario we can consider return 0 or return null. So the time complexity of binary search is O of log n, and worst case complexity, as we discussed, is omega of 1. For linear search it is O of n, the best case time complexity, and worst case time complexity is once again omega of n if we find the element in the starting of the array only. So, and we can define time complexity as a number of steps or the number of operations required to execute the same algorithm, execute the same code, or we can say execute the same thing. The different number of steps taken would be the time complexity. Now, omega is lower bound time complexity and O is upper bound time complexity. Both can be same, omega and O, and if both are same, omega and O, we will go to theta, which is another form of complexity we use to define and segregate different type of programs, which is also, and these notations are known as asymptotic notations. So now we are gonna continue with struct, but I think I have completed my time limit of recording video, so let me see for a second.